All right, let's kind of change gears here. Now, those were exponential equations. Okay, now we're going to switch to log equations. Okay, now we're sort of going to separate them into two categories here. One where we have a single log, and then one where we have multiple logs. And when it has multiple logs, there's no clear-cut way to do them. Okay, but if it's a single logarithm, it's not that big of a deal. Okay, so let's just look at a single log first. Okay, so a single log or just one log. Okay, all right, so if I have one logarithm, all I really have to do is just a couple things. Okay, you isolate it, and when I say it, I'm referring to the logarithm. Okay, and then here's probably the most important step here, is you switch it to exponential form. Okay, and if we can't remember this step, or if you don't know what I'm talking about right here, then we're in trouble. Okay, because this is that fundamental definition of a logarithm. Okay, it says this, what, log base b of x equal y. The exponential form is what? B to the y equals x. Okay, and that has to be automatic. That is the definition of what a logarithm is. Now, let's talk just a minute. I did a log base b. All right, so what if it's common log? Common log doesn't have a base written down there. It's 10. Okay, if it's a natural log, then it's e. Okay, now from there, all you have to do is just solve it, and then you have to check. Okay, now when we say check, we're really just looking for one bad thing to go wrong. Okay, and this is this. I can't do the logarithm of something that would be negative. Okay, so in other words, this value that I take the log of has to be positive. If it's not, then that solution that I got would be extraneous. Now, all right, what I take the logarithm of has to be positive. It can't be negative. Okay, so I can't say the log of -2. You can't do that. Okay, so if you got a solution that made you take the log of something that would be negative, that solution would be extraneous. Okay, now most of the time with single logarithms, you don't really have any trouble with that. It's when you start having multiple logarithms is where you get to issues. Okay, now let's look at an equation here, or let's look at a couple of examples that just have like one logarithm. Okay, I'm going to do number 53. Okay, this one's got, all right, log base 4 of x plus 5 equals 3. Okay, y'all see where I'm at number 53. Okay. All right, so first thing, we said isolate the log. Now, the log really isn't the word log. What's really the log here? Yeah, x plus 5. Okay, so is it pretty much already isolated then? Yeah, so if I had a number in the front, I would divide it. Okay, what if, well, I'll come back on that question. All right, so now let's switch it to an exponential form. So what would exponential form say? 4 to the third equals x plus 5. Okay, and so 4 to the third power, you know, if I didn't know it, I could push it in my calculator, but 4 to the third is 64, I think. Okay, you're right, subtract 5. So like from here, you just solve it. So 64 minus 5 would be 59. Okay, now here's what we're talking about checking for extraneous solutions. Is that if x is 59, is that going to make me take a logarithm of something that's negative? No. Okay, and most of the time with single logarithmic equations, you're not going to have to worry about extraneous solutions. It's when you have a couple of logarithms that you get in trouble with that. Now, let's just play what if here. All right, we may not work this one out, but what if this was written this way? Okay, so notice I've left off the parentheses. Right, you would subtract the 5 first. Okay, now do you want me to work that out, or just want to? Yeah, okay. So the thing is, the 5 is not a part of the logarithm in this case, so we would have to get rid of it. That's part of isolating. So we get log base 4 of x equals -2, right? Okay. And so now exponential form and say what, 4 to the -2 power equals x, which 4 to the -2 power would be 1/16. Okay. So really and truly though, with the directions, you're going to be able to just type it in your calculator and give it in a decimal form. Okay. So I don't even know what that is in a decimal form, but all right. So really be point, if we did 2 decimals, 0.03. Okay. Now, is that, I don't know. Okay. Let me type it in. 1/16. Okay, I'm sorry. I just heard the 2/5 part. I didn't hear the 6. That's why I did that. All right. Now, let's talk about some differences here. Or let me just do one more of these with a single log, okay? Yeah, we're doing good. All right, let's look at number 59. Okay. All right, this one has 5 times the natural log of 2x equals 20. All right, so right, you got to divide by 5. Now, the truth is, you wouldn't have to divide by 5, even though that's probably the smartest thing to do there. Okay, really was something else you could do with the 5. Right, you could put it as the power, but that really wouldn't be that smart. Okay, it's much easier just to divide it off. Okay, so that's going to give you 20 over there. Not 20, 4. Okay. All right. Now the only difference between this one and my last problem now is it's not a log of base 4 or log or common log. It's a natural log, so the base is e. So you get e to the 4th equals 2x. Okay. Now, so all we have to do to solve for x now is divide by 2. And I know y'all are thinking, well, what's e to the 4th? Well, the calculator will do that for me. Okay. So I kind of wait to the end to evaluate the e part. So the way you can get e, you remember what e actually is here? The approximation value, it's up there. It's about 2.7. Okay, it's an irrational number. It keeps going, but you have an e button on your calculator. It's the natural log button. Okay, so you have to hit second and then natural log. And notice it already puts e raised to a power. So it's like it already knows that you're going to raise it to something. Okay, so we're raising it to the 4th. So here we go, e to the 4th. Now you got to knock it down out of the exponent. And then what are we going to do with it? Oh my, yeah, just divide it by 2. Okay, so you get about 27.30. Okay, now talk to me here. Does that make sense with like a single logarithm now? The single logarithm problems aren't going to really give you any trouble. Okay, it's the ones with multiple ones. Yes. Do what now? Nah. The natural log of e to the 4th would be 4. Okay, and Mariana, what some people want to do right there they see that and they want to take the natural log on both sides. Okay, but if I took the natural log on both sides, I just wind up with what I had there. I just like running a circle. Okay, so when you get e raised to a power, you can evaluate on it on your calculator. It's when you have e raised to something that's unknown is when you get in trouble. Okay, that's when you got to use the natural log on both sides. Okay, now when it comes to multiple logarithms, really the only thing, you can't have like steps. You can't say, no, 1 do this, 2 do this. It doesn't work that way. Okay, you're going to just really have to think about it. Okay, so all I can do for you is kind of offer you is right this way, so multiple logs. All I can offer you is just some strategies. Okay, so do you understand what we mean by multiple logarithms? You're going to have more than one in the problem. Okay, so if I have 2 logarithms, let's say that they're on the same side of the equation with each other. What's something you think I can do if I have like 2 of them? Combine them. Okay. Now, so how can you combine the logarithms? How can you combine a log plus another log? Right. And what if I have a log plus another log, you can multiply. If I have log minus another log, you can divide. What are we using there? Properties. Okay. So here's a strategy. You can use your properties to combine them. Okay. Now, that's if they're like on the same side of the equation with each other. Okay. They're not. Okay. So that's one nice thing about it. All the logarithms are going to have the same base, so they'll all be like a natural log or something like that. Okay. Now, no, this is not review. Okay. We're doing this. All right. All right. Yeah, we're doubling up. Now, all right, here's another thing. All right. Let me phrase this one, okay? If you can evaluate a log, okay? Well, we'll talk about this, what it means, evaluate. Evaluate the poop out of it, okay? Okay? I mean, evaluate that sucker, okay? Now, let's see what we're talking about. So, if I get like a bunch of logarithms here, plus another logarithm here, and then we got a log, but we see this like log base 2 of 8. What is that? 3, right? Because 2 to the third is 8. So if I see one that I can evaluate it, okay? No, you just say 3. No, you evaluate the poop out of it, okay? I mean, you know, go for it. Now, the other thing, okay? All right, if you have logs on both sides, okay? Yeah, okay, if you have logs on both sides. Now, this is only the case where you couldn't have like multiple logs on both sides, but like 1 log on this side, 1 log on that side, and that's it. Nothing else, okay? If you have logs on both sides, then you can cancel, okay? No, just cancel. Let's evaluate, that's all. Now, so what I'm talking about here, let's do like an easy equation. If I have like log base 4 of 2x plus 1 equals log base 4 of 3x minus 2. Okay, so notice what I'm talking about. I have logs on both sides, don't I? Now, there's nothing else, is there? There's not like a plus 2 or adding another log to this log. It's just logs on both sides. So if that's the case, what you can do is just cancel those logs off on both sides. And then what you got left is nothing, okay? Right, you just solve it. Now, there again, you got to check the solution. Okay, so we'll check it. Now, I would subtract 2x from both sides, add the 2 over here, so you'd get 3. Okay. Now, here's the thing. Remember what we said about checking the solutions? A logarithm can never be negative. Okay, so if x is 3, would that make that negative right there? No, it wouldn't. Okay. Would it make this one negative? No, so it's okay. Okay. And extraneous solutions really pop up when you get a lot of logarithms. You get multiple logarithms, that's when you start getting some extraneous ones. Okay. Now, let's look at some examples now. All right. So you got to keep these things in mind here when you solve them with multiple logs. This is it. Okay. All right. So let's see. Let's look. We'll figure that out later. All right, let's look at, I think. All right, let's look at number 65. Okay, now this one, I'm going to tell you, it's really challenging here. I almost didn't want to do this one with you first, but okay. So now, we've got multiple logarithms. Right. So all we have to do is just put them together and make it one logarithm. So once I get it to one log, we can go with it. Okay. So what we're going to actually do to put these as one log, we're going to use that power, not the power property, the product property. We're going to multiply them. So I'm going to have to say x times this, so I would have to distribute it. Okay. So you get log base 5 of 4x squared minus x, okay, equals 1. Nuh-uh. Right. See, if I had, let me show you what happened there. If I had this log equal this log right here, this was an equal sign, then I could do that. Okay? So if we're adding or subtracting logs, we're going to use our properties. Okay? Well, you couldn't do that because you'd have that 1 over there with it. Yes. Okay. You see what we're saying, Caleb? You're saying if you take this one over, you're going to have that 1 over there, and you couldn't do it then. Now, from here, we just go to exponential form. So now this would say what? 5 to the first power, which is 5, equals 4x squared minus x. All right, shh, one at a time. What? Talk. All right. Now, listen to me. Shh, listen, I'm going to fuss. This is what I told you about, was that fundamental definition that you had to know to do these problems, okay? All right, listen. If you have log base b of x equals y, the exponential form is b to the y equals x, okay? So 5 to the first power equals 4x squared minus x, okay? Right. See, yeah, 5 to the first power is just 5. All right, where did you get lost at? Talk to me. Are you getting lost from here to here? Okay, we're using the product property. If we add 2 logs, we're actually going to take the logarithms and multiply. Okay, so if I was, let's just say a second, what if this was subtracting? Then I would take x and divide it by that. We'll do one like that next. Okay, now notice from here, when I did that multiplication, it turned into a quadratic, didn't it? Okay, so we're going to have to set it equal to 0 and probably factor it. Okay. Yeah. This is why I didn't really want to start with this one, because it was pretty bad. Now, let's factor it. Let's see, factors of 20 that subtract to be 1. would be 5 and 4, and I'm going to have to split it because I got a leading coefficient. Now, I think the one in your homework is not going to have a leading coefficient, so it's not going to be that bad. Now, this one's going to be minus 5 plus 4. All right, so we can factor out an x here, so that leaves me with 4x minus 5, and then just a 1 on that one. So we're going to get 4x minus 5 times x plus 1 equals 0. Okay, so now let's write out our solutions here. We're going to get 5/4. Okay, right. Right, this one's going to be extraneous probably. Okay, all right, let's look. X is 5/4. You have to check, and we're going to go back, and we got to make sure that these logarithms would be positive. All right, so if x is 5/4, that would be positive. Now, is 4 times 5/4 minus 1 going to be positive? Yeah. Okay, if you weren't sure, you could throw it in the calculator and make sure. All right, now, what about -1 though? No, you'd be taking the log of a negative number. It wouldn't matter if it was negative or positive here. If it's negative in one of them, it's over. Okay. Same thing. Okay. Yeah, same thing with a natural log. So -1 is extraneous. Okay, so we cross it out. All right. Now let's look at another one here where we would use the same strategy as sort of putting the two logs together. All right, y'all look at number 70, or yeah, 69. Okay. All right, this one you had log base 2 of x plus 2 minus log base 2 of x minus 5 equals 3. Okay, and let me tell you something about these log equations on your test. I made out your test. There's probably more log equations on it than anything. Okay, now let's look. So we have multiple logarithms. Okay, so right, we can use the properties to put them together. Now with subtraction, right, we're going to divide these. So we're going to get log base 2 of x plus 2 over x minus 5. Okay, now talk to me. Did y'all follow that okay then? Okay, now once you use your properties, you only have one logarithm, so you're back to a single log equation. So isolate the log, and then the most important thing, go to exponential form. So right, yeah, 2 to the third equals x plus 2 over x minus 5. Okay, now probably what you should do here, instead of writing 2 to the third, go ahead and write what it is. Okay, and so 2 to the third there is really 8. Okay, now how would we solve this though? You have any ideas? Right, you could do it that way. Okay, so he said you multiply both sides by x minus 5. I would do this. You just need to do both sides. No, I'm going to cross multiply. You can do it that way too. Okay, and that would be a little bit easier. All right, so 8 times x minus 5 will give you 8x minus 40. Okay, and be sure when you cross multiply that you distribute. Right. So this one's actually a little bit, the quotient ones are a little bit easier because they don't turn into quadratics. Okay. Now, the other one, 1 times x plus 2 would be x plus 2. All right, now from here, it's nothing. Okay, so I'm going to subtract x from both sides. That'll give me 7x. And we'll add 40. This one comes out nice and even. Okay, so it'll be 42. All right, so x would be 6. Okay. Not always. Okay, you can still have extraneous solutions with these. Now, let's look and let's check and see if 6 is okay. So if x was 6, this would be 8, which would be okay. This one would be 1, so it would be okay. All right. Now, so you can use, that was that first strategy, you can use properties to kind of help you out there, to put two logarithms together. Okay, now let's look at 71, and let's see if you guys can spot something on this one. All right, this one's got 2 log base 3 of x plus 4 equals log base 3 of 9 plus 2. Now we don't really have time because I got like 2 more problems here. Yeah, they're both base 3s. No. You don't have to. You could do that. You could, but right, you can divide by it, but then you've got all this junk over here. Nope. That's 4. What is this? That is 2. All right. You can evaluate it, right? So the chances are, if you see a logarithm that doesn't have an unknown on it, you're going to be able to evaluate it. Right. So now, did y'all see where I got 4? All right. 3 raised to what power would give you 9? 2. This is just 2. And so 2 plus 2 would give you 4. All right. All right. Right. So now, did y'all see why I didn't want you to use the power property now? Because now we can get rid of it. Okay. It's much easier to get rid of that instead of use the power property. Okay. All right. Now from here, it's not real hard. So what? 3 to the second power equals x plus 4. Now 3 to the second power would be 9. Okay. All right. So x would be 5. Okay. All right. And let's check it. That would be positive, so it would be okay. All right. Now let's look, and we won't like do another example like that, but what did I do with it? Yeah, this one. All right. Find another one like that. All right, like number 72. Look at this one, okay? I think that's the actual one that, yeah, you're going to have to do 72. So like right here, this. What is this? That's just 2. Okay. Let's see if I can find another one. I don't think I really see any other ones kind of like that. All right, here's another one. All right, number 85. All right, number 85. That's 1. Okay. Now, there's some here that you can't, or you could do number 84 would be the same thing. That would be 2. Now, but look at number 86, though. Okay. Log of 14, could you evaluate that? Okay. 10 raised to what power is 14? We don't know. Okay. So you can always evaluate it. Now, let's look at that case, though. Okay. So what if we can evaluate it and we've got logs on both sides? All right. All right. Let's look at 75. Yeah. Okay. All right. This one you got log of x plus 4 equals log x plus log 4. Now, you got log 4 over here, but you can't evaluate that. Now, if it was log base 2 of 4, that would be 2. All right, but that's log base 10, so you can't evaluate it. So, all right, I'm not sure where this is going, but we can evaluate. So let's at least figure out we need to use our properties there, probably. Okay. So it'd be log of x plus 4 equals, now, so what will we do with x and 4 right there, really? Multiply. So it'd be the log of 4x. Now, all I have on both sides is just logs, right? So you can just cancel them out. So all I got is x plus 4 equals 4x. All right, well, subtract the x off. That would give me 3x equals 4. Okay, yeah, so x would be 4/3. Okay, so that's the case where you're using like the canceling out strategy. Okay, now, let's see how we do it. Let's maybe try one more like that one. All right, let's look at number 83. I think we need to do like 2 more here and we'll be good. All right, this one's got 2 log x minus log 7 equals log 112. Okay, so here again, we couldn't evaluate this. We couldn't. Okay, so if it was 100 right there, it would just be 2. Okay, now, so what do we need to do? Probably what, put some logs together, maybe use the quotient property. Now we're going to run into a little bit of trouble if we can't use the quotient property first. We got to use the power property. Now a lot of times we just divide this number off, don't we? But we can't right here because it would mess up all this over here. Okay, so you're going to have to use the power property. So it would be the log of x squared and then divided by 7 equals the log of 112. Now we can cancel out on both sides. Okay, so we get x squared over 7 equals 112. Right, cross multiply. And a lot of times when you use the quotient property, that's what you're going to end up doing, is you're going to cross multiply. So you get x squared equals whatever 112 times 7 is. Let's see. 112 times 7. And then what about from there? Square root. Okay, so square root of that, 28. Okay, now really we should say plus or minus. All right, now, but I'm not. Right, I'm not going to put plus or minus 28 because it can't be negative 28 because I'll be taking the log of something negative. So it would only be 28. Yeah. Yeah. Right, instead of multiplying, but instead of cross multiplying, y'all see what she's saying? You could just multiply by 7 on both sides. Okay. All right, let's do one more. All right, stop packing up. All right. Let me do number 89 with you, okay? Okay, we'll do this one and then we'll go, okay? Yeah, we may run out of time, but it's okay. Oh, this one's going to be pretty long. No, okay, because you've got the subtraction. Okay, now, so here's the idea. Could we put them together on both sides and then cancel? So this would be on the left side, the natural log of x minus 2 over x plus 3. I'll see what I did there. Use the quotient. Now, same thing on this side, natural log of x minus 1 over x plus 7. Now, I can cancel them off. Okay. Now, you would have to cross multiply. So it looks like a quadratic, but the x squares cancel. So just not. Okay. All right. Be sure you already wrote those even ones down that you're supposed to do. Okay. Pretty much. Yeah. It should be in your email.